Okay, April 11th, I guess we should put a title. This is, grab that door. Okay.
Today's,
We're creating
Damn,
quadratic models.
That's creative.
Oh,
that's sick.
Okay, so we've got several points on a graph here. From looking at it, we get the idea that this is probably going to form some kind of parabola. So what we're going to do is we're going to find the coordinates of each of these points to the best of our ability. So we'll say this is roughly 1 and 2. We got another one here. This is about 3 and 5. Okay. Now, this won't be exactly a parabola, but we're trying to find what we consider like a curve of best fit. Just like you guys did lines of best fit the other day. Or sorry, the other year. Not the other day. Another point here at 6 and 7. And another one here is at 8 and 2, it looks like. Okay? So you got several points here. We're going to estimate where our vertex is. Now, looking at this, we could think this is it, but it's probably going to fall somewhere in between these. Okay? So we're going to estimate the vertex. I guess we'll put it in blue here. We'll say the vertex is right in between. So about 5.5 and the number 7. Wow, that wouldn't work if I was there.
7.1.
Let's go 7.5. Say it's even higher. Okay? So our estimate is 5.5 and 7.5 for the vertex. We need to create a quadratic model from this. Okay? So what that means is, because we're looking for something that has the vertex, this is the information we have, we're going to use vertex form. Now we went over standard and factored. We're going to use our vertex form to solve this. So we have y is equal to x minus h squared plus k. So remember, we have our a, which deals by what factor this parabola is stretched by. H is the x value of the vertex, and k is your y value of the vertex. Okay? So our vertex in this one is 5.5 and 7.5, which are our x and y values. They're also the h and k value of what we're trying to find.
wait, so is this one?
So this is a side note. The last thing what we're going to do, we're going to plug in our h and k, and then we're going to solve for a. Looking at this, Jaden, what kind of parabola? A is going to be what? Positive. Yeah, it's definitely going to be negative because it's a parabola facing downwards. We just don't know what the number is going to be. Okay? So we're going to plug these values into our vertex form. Y equals a x minus, our h value is positive 5.5 squared plus, and our k value is positive 7.5. So our form is y equals a x minus 5.5 squared plus 7.5. Okay? So we have a good chunk of the information, but not all of it. What we need to do is we need to solve for our a. But the problem is I have 3 unknowns. Don't know this y value, I don't know this a value, I don't know this x value. Is there any information I can use to find out at least 2 of these values anywhere? I can find the y and the corresponding x. Where can I find that information? On the graph. I have tons of different points here. Okay? So we're going to use one set of points. Let's try the 3 and the 5. That's one of the points on this graph. So we know one of the points is 3 and 5, which means that's definitely an x and a y value. So we're going to use those to plug in for the x and y values. And then isolate a. That's exactly right. Okay? So our y value is going to be the number 5 is equal to a. X was 3 minus, 5.5, not 2.5. 5.5 squared plus 7.5. Okay?
So you can use
any point as long as it's on that parabola. So we use some of the information they've given us. So now what we got to do is essentially just figure out what a is. So according to Ben Mass, I'm going to equate what's in this bracket here. 5 is equal to a. What's 3 minus 5.5?
Negative 2.5.
Good. Squared plus 7.5. Then we're going to square our negative 2.5. A times, what is negative 2.5 squared? Is it going to be positive or negative?
Positive.
It's going to be positive.
9.
9? No, it won't be 9. Oops.
Wait,
6.
We multiplied by itself because it's squared. So 2.5 squared, 6.25. And because it's a negative times a negative, it's a positive number. So 6.25 is our answer. And then what's 6.25 times A?
6.25A.
Yeah, we just rewrite it. We put the 6.25A plus 7.5. Now remember, our goal is to isolate A here.
5 minus 7.5.
Okay, so we do reverse bedmass to isolate something. So I'm going to move, even though this is 6.25 times A, and in bedmass we would deal with that first. When we're trying to isolate the variable, I do reverse. So the last things I normally equate are addition and subtraction. They're going to be the first things I move. So I'm going to move 7.5 to the other side. What's it going to become over there? Yeah, 5 minus 7.5 is equal to 6.25A. What's 5 minus 7.5? Negative 2.5. Whoops. Yep. Sometimes my brain and my hand don't work. There we go. Negative 2.5 equals 6.25A. And how do I isolate it? A?
Divide by 6.25.
6.2.
What's it going to be?
A equals
0.75.
Ready?
Wouldn't be negative 2?
Sorry, let's bring this over.
Negative 2.5, yeah. 3. Because
Why is it going to be negative 2.5?
times them together.
Okay, it's negative 2.5, exactly what he said. Because remember, we squared 2.5 and got 6.25. So if I was to divide it back in, it's going to be that same number. So our A is negative 2.5. Now, the question is write the equation. So the equation is y is equal to negative 2.5 x minus 5.5. That was one part of it, plus, don't forget squared, 7.5. So there is our answer. The entire page. Don't worry about that. You can't see it on the video.
Sir.
Excellent. I did write this down wrong. Remember, this is a fraction where the lowest number is on top. When I put it into the calculator, I divided it in reverse. This is 2.5. Divide 6.25, so it's 1 over 2.5. Okay? 1 over 2.5. Or, again, we'll put it in the calculator so you guys can see exactly what those numbers will be. So it should be 2.5 divided by 6.25. Okay? 0.4.
So negative.
So I did write that in wrong, my mistake. Thank you for noticing that. Negative 0.4. Okay? So that's what we were looking for. Negative 0.4. So this equation would essentially be this. We're going to try to put a curve of best fit. It would be roughly that model there. It goes through those dots. That would be our quadratic.
Another 7.